Hello friends, welcome back to the bench. Our patient today is this beautiful i5 7th generation. Now the question is, can you fix a broken CPU? Now do we know this one's broken? Yes, the Z170A board that we were working on that wouldn't recognize i5. We did the BIOS reflash in case it just wasn't compatible. But in the comments I received a lot of information, mainly like there's no way this one is not compatible, which yeah, it definitely felt like it would be unreasonable. So the advice that I have been given is to make sure that the CPU actually works. It's a great advice, which I didn't do, and well, what are you gonna do? Now we know that this is broken, right? It doesn't work. It doesn't work on the fully functional board that has i5 installed on it, i5 8th generation, so that's slightly newer. So definitely it is compatible with this, and it doesn't work with this one. So that's how we eliminated that this definitely doesn't work. Now, can you fix a CPU that doesn't work? There are two cases, two kinds of faults that can be fixed. Case number one is broken pins, bent pins, that kind of stuff, physical damage to the CPU. Now, obviously, this isn't the case in this CPU because it's 1151. So instead of having pins on the board, we have pins, or instead of having pins on the CPU, we have pins on the socket. That's why sockets break and not CPUs. Which one's better? Hard to say. Fault number two are the capacitors. So on the back side over here we have quite a few capacitors. These are ceramic capacitors. And how do they break? They break when you hit them. When you drop the CPU, they hit the hard surface, which basically if you do this right on a hard surface, you're risking one of the capacitors to cut short. Now, why would capacitor cut shorts? It's actually pretty simple. The capacitor is built from many plates like this on each side of on each terminal of the capacitor, right? There are many of these on this side, many on this side, and they are assembled in such a manner that they don't touch, creating capacitance. Now, the capacitance of the capacitor is described as the size of the plate divided by the distance between them. So this is slightly counterintuitive because you would think that the more room you have between the plates, the more capacitance you have. But it's the opposite. The closer they are, the higher capacitance. The farther away they are, the lower the capacitance. And likewise, it affects the maximum voltage. The closer they are, the lower the breakdown voltage. The farther away they are, the higher the voltage. That's why we have two capacitors over here. These are electrolytic, but the principle is the same. They are exactly the same size, right? But this one is 47 mic, this one is 4700 mic. 100 times more capacitance in this one. The reason is that this one is for 25 volts and this one is for 400 volts. So to increase the voltage of the capacitor, we need to move the plates away from each other. That gives us higher voltage, but lower capacitance. That's why these are the same size and have very different capacitance. Now what happens when you drop the capacitor, ceramic capacitor, it bends and two plates are starting to touch. That is our short. Now let's confirm that we do have indeed a short, and the procedure is very simple. Maybe let's hook it up like this. That should be easier. And we're going to confirm that with a multimeter. So the resistance between two electrodes of the capacitor, two terminals of the capacitor, should be roughly within the ranges of around 3, 4, 5 ohms. So it's going to be a low resistance for sure, but we don't want to see the short. So let's touch these two, and we have 0. It's slowly going down to 0 because there's capacitance on the other side, obviously. We got 0.1, 0.1, 0.2. So perhaps not this particular cap is shorted, but some cap on this line is shorted. Now let's check maybe this one. And here we have 6.3 ohms. So this line is okay, this cap and this line. Now this is kind of what we expected, because if that is the fault, then the caps that are the thickest are going to take the fall. So these are the ones that are going to get shorted if this is our fault. Now, is this definitely the fault? I would say very likely, because either the short is on one of the caps or the short is inside the CPU. But usually, from my experience on Surface laptops or Surface Pros, if the CPU is shorted on vCore, it's almost never the plain 0 ohms dead short. It's usually closer to 1 ohm. It should be 3 ohms to 6 ohms, or 9 ohms even in some cases. But when it's shorted, it's around 1 ohm, not plain 0. Now, that's what you would expect. And also, we don't know whether this is short on the vCore or VSA or VIO. But judging by the size of the capacitors, vCore is always gonna grab the most current. So most likely this is vCore. We could confirm that, but it's not the information that we necessarily need at this point. I mean, if we find out this is vCore, most likely it is. But if we confirm this is vCore, we're still in the same spot. We're still in the same place. So how do we confirm? How do we fix? So what we can do is inject voltage to these two terminals and observe on the thermal camera what happens. One of two things is going to happen. Either one of these caps, and it's going to be one of these big caps, is going to light up. We're going to see a nice little spot that is heating up, or the entire CPU is going to start heating up. If the entire CPU is going to start heating up, that means the short is somewhere inside, and there's nothing we can do about it, or at least nothing I can do about it. Sure, can you decap it, like take off this protective layer and look inside? Sure, but I don't think, inside of the CPU there are millions of transistors. Transistors go short when they are overvoltaged, and they can go short due to overheating. So if the CPU was not properly cooled, there is thermal throttling inside, meaning the CPU should never heat up to the temperature that would break it. It should start throttling itself to limit the temperature. That will obviously manifest as a very poor efficiency, and maybe system freezing and generally going really slow. You probably have had that problem on at some point, that the computer completely slowed down and it's sluggish, and you discovered that the fan stopped working, or there's such a massive amount of dust on the heatsink that the CPU is just at high temperature. Or you just check within the software and see that the CPU is at 82 degrees, or 95 degrees or what have you. Basically, temperature is too high. So that's typically what you expect. The CPU is not going to burn itself, but we're going to have our answer once we inject the voltage. If the voltage shows a nice little spot, or if the temperature shows up as a nice little spot somewhere here, we should be able to pinpoint which capacitor is shorted. And if we cannot, since it's already broken, maybe I will just remove all the capacitors. Now, could you connect the CPU without these capacitors, and what are these capacitors for? The easiest way to kind of visualize that, because on the board there's plenty of capacitors on the back side of the socket, the CPU socket on the board. There's plenty of capacitors coming on the right next to the CPU socket, and these are big electrolytic capacitors right past the coils, plus ceramic capacitors. There's a lot of capacitance on that line, definitely. So why do we need capacitors right on the CPU? So the best way to visualize that is we have a power supply over here. On the output of the power supply, we have capacitance. We have decent capacitance, right? At least 2000 mics. Now we're routing the cable to our load, and now if the load requires a lot of power, a lot of peaks in current, then we're going to notice that the voltage here is not going to be the voltage here, right? So even if we increase the capacitance here, we're still going to have voltage drops over here, because our wire acts like a resistor with very low resistance, but resistor nevertheless. That's why right before we connect it to the device, on this side of the wire, we install another capacitor. And those capacitors, typically on the chips, on the ICs that require such spikes, are typically installed right by the IC, right by the chip, right by the pins that are VCC and ground. That ensures that we have enough boost of current right by the chip. If the chip requires more, we can maintain stable voltage. That's why these capacitors are here on the CPU. They need to be as close as possible to ensure stable voltage. Now, what would happen if we connected it without all these capacitors? Stability issues. I would expect a lot of stability issues. CPUs are built in a way that they can self-correct, retry. They're not necessarily going to crash your system, but due to error correction and maybe throttling, maybe whatever the CPU does to get the job done, that's going to be more time-consuming, more energy-consuming operation, so the efficiency of the CPU will drop way down. All right, enough talking. Now, let's solder in the wires. And actually, before we do that, let's protect the CPU, what do you call it? The pins, so we don't short to the pins, we don't send voltage where the voltage shouldn't go. Let's just insulate it real quick. Alright, just so we don't touch it with the wire. Now, as far as the updates of my job search, I finally got a recruiter, a little more resourceful recruiter. I'm expecting some interviews on Monday, maybe Tuesday. Actually, when I talked to the recruiter, because that previous one, that first one I told you guys about, I still haven't heard anything back from that guy. This guy, on the other hand, made a completely different impression. Obviously, he asked me of all the stuff that I've been working on, and the previous companies and stuff like that, normal, typical stuff. But also gave me a lot of pointers, because I'm not the person that can that has the ability to, as they say, sell yourself, right? To kind of convey efficiently how competent you are. So he gave me a lot of pointers regarding that, like yeah, you should what was it? Because I was talking about one achievement I had at work, and he said, well, see, you should open with that, and you should keep it. That should be that one sentence you have to say about that company, that kind of stuff, to be efficient, because not everybody has time to just kind of go through your career and spend maybe an hour on the call with you to just kind of learn where your competencies lie. So that was very valuable to me. Also, it picked up a little bit of optimism. Maybe finally something's gonna start happening, but again, it's all hybrid, local jobs, not remote. I suspect that's gonna give me a lot better results than I've had so far looking for remote. There's just there's actually, so I live in just north of Atlanta, and the office is in downtown Atlanta. So I'm not crazy about the traffic, but I can do it. But the other company, also local to here, is in, I forgot the name, but it's like next town over. Pretty close, so I don't have to even get on the highway to get there. So that would be a lot better, but they want 4 days in the office. And the one downtown Atlanta want 3 days in the office, which is reasonable. I mean, I can do 3 days, and maybe that'll. I've been kind of stuck at the house for the past years, so maybe that'll do me some good. But we'll see. And that company, actually, they're like all about Drupal. I haven't worked in Drupal in a long time. Not that it would matter, actually, because it's PHP. I've worked with so many obscure pieces of software that I had to reverse engineer or hack away. So I'm not afraid of or intimidated by any technology that utilizes PHP. Okay, now the moment of truth. So if we see a nice little spot, the polarity doesn't really matter because it's shorted. But if we see a nice little spot, we can fix it. If the whole CPU is gonna start getting warm, this is gonna be a bust. Now, one good trick, especially when having a thermal camera that is not high resolution like this one, or without the lens to give you a good zoom, a good trick is to put your device, in this case CPU, in the freezer or in the fridge for some time to let it cool down. Then the heat spot is going to be very prominent. It's especially useful when the shorted component causes the rest of the board to heat up very quickly. So either you can just do the clicking, right? Just give it pulses and see where it flashes, because if you just apply voltage, it just quickly heats up everything, the whole area around. So either do clicks or cool down the device. That will make it easier to pinpoint it. Okay, let's record this. We are recording, and I'm injecting 0.7 volts right now. Yeah, unfortunately it's none of the caps. So there was no heat spot, and we're grabbing 1.6 amp. So it's, yeah, nothing. Yeah, at 1.6 amps, you would expect, if this was a shorted cap, we would see it now. It's it looks like it is indeed a cord that is shorted. Shall we do 0.8? Let's do 0.8. We are limited to 2 amps. Now we're at constant current. Yeah, nothing. Nothing. I don't feel it getting hot, but see, nothing. Nothing's getting hot at 2 amps. Now, why is the CPU not getting hot? Why do we not see a heat spot on the CPU, even though it's grabbing 1.5 watts? Because CPUs are very good at dissipating that heat, spreading it around and dissipating it. That's too bad. And they even, yeah, they stay cool. See? So these black spots over here are the ones, are capacitors, which, if they were a culprit, we would see nicely lighting up now. But they are staying cool. Nothing. Let's let's give it 3 amps, so it's 2.1, not much difference. And if it was a cup, we would see it right away. Yes, and the CPU got slightly hot or slightly warmer. .31 degrees. Yeah, that's pretty much all she wrote. So this is not gonna be a fix. This is shorted core. Now which core? Well, this is 10 core CPU. And it doesn't really matter which core, because all of them are connected to the same power. So if one of them is shorted, they're all shorted basically. Now if we remove the cap, we could probably see the area in the CPU that is shorted, that is grabbing all that power. But even if we do, that doesn't really give us anything. Nothing we can do beyond here. If it was the cap, we could fix it, but it is not. Well, at least I hope you learned something about the capacitors and their faults. It is maybe not common, but it is worth checking. It is always worth checking, because if it was a cap, it would be relatively easy to repair. Now, final words on my testing on the Z170A. Shorted CPU explains the behavior that we had, that it worked on i3, then I updated reflashed the BIOS, I put i5, it didn't work, then I put i3 back on, and it still didn't work. Now what happened there is probably the board went into thermal shutdown. I even commented on how warm the vCore heat sinks were. If this is shorted, the board you would expect it to detect that. But if your power ranges are, or your resistance of the load is at 2 or 3 ohms, it's very close to the short. Plus all the caps that you have, all the capacitance that you have there. The vCore power supply can actually recharge the caps even if there's a short on the other side of the line. It will still maintain the voltage it needs to maintain, because that's what it's built for. And it's very hard to detect the difference between 0 ohms and 2 ohms, right? Effectively, when you connect power to the line that has a lot of capacitance, then effectively, initially, when you start delivering power, there's going to be a short on the other side, because all the caps want to charge at the same time, and effectively, that's short. That's going to be 0 ohms when the caps are charging. So the power supply is prepared to deliver a lot of power very quickly and even ignore that there's an abnormal power consumption, which means this short has been supplied, the CPU has been supplied with enough power and tens of watts from the power supply, which resulted in the CPU heating and the control circuitry heating, mainly MOSFETs. That's why we have those heat sinks. And since I kept the board on for a little while, what was it, few minutes, that would be enough to overheat the board, overheat the MOSFETs, and cause the board, the vCore, to go into shutdown, the thermal shutdown. That's why i3 didn't work right after I replaced it. I replaced the i5, right? So that would explain it. That's why it worked the next day or the whatever following day, when I connected i3 and reverted BIOS to the original version, it did start. The act of reflashing BIOS had nothing to do with the board's fault. It was the CPU. So thank you for the suggestion. That was, as you can see, that was very useful. Too bad we can't fix this one, but hey, you can't win them all. And I wrote the guy that sold me this this CPU, and I haven't received the answer just yet. But we'll see. Maybe he'll take it back. I checked. I actually paid for it $24 or something like that. So for i5 7th generation, that is relatively good price. They go for closer to $50. So, you know, even if I can't return it, you know, it's not the end of the world. But that means that the rig, there's nothing wrong with the board, and we didn't need to reflash it. Everything was fine. It was just the CPU that was faulty. All right. Thank you guys very much for watching. I do appreciate you, and I shall see you in the next one.